First, I'm going to start with a quick introduction to containers, Kubernetes, and Apache Airflow. Next up, I'm going to tell you why you should care about designing for scale. And then to our main act, what we all did wrong. An issue with a database being lost, overcrowding our database, issues with network scaling, some application settings you might want to look into, and an upgrade to Airflow 2.3.0. To top it off, we will do the Q&A session. So what are containers? Containers are a piece of software which contains everything you need for your application to run. Think of your web server, application server, maybe even a database server, but also the libraries and all of that. So what's Kubernetes? Kubernetes is a platform which will provide you with some runtime. You can get some disks, some storage, and some CPU cycles out of there, but it's more than that. It's also an orchestrator which will monitor the workload on your platform. You specify that you want things to be run in a certain time frame, and from that point, Kubernetes can take it over. You set the autoscaler to running, and if your workload starts increasing really hard, Kubernetes will detect it. It will autoscale your workload and make sure that everything is still handled in time. So it's like temporary workers in your job. Then, what's Apache Airflow? Apache Airflow is an orchestration tool for data, but it also allows you to design some data flows. You can do multiple things with it. For example, call ADF, Synapse, or Databricks. But everything you can call with Python or with a REST API, you can use via Airflow. So, why should you care about designing for scale? When you start to grow in number of users, your environment will start to behave very differently than it does with little users. By default, the Airflow Helm chart really works out for little users. But scaling up, you might start to get an availability or performance degradation. In addition to that, with a bigger user base, your downtime becomes way more expensive than it did before. If thousands of developers are waiting for you to get your system up and running or responsive again, it costs a lot of money. And not to speak about all your downstream systems that might depend on you. Think of the report your manager really needs for that business deal. It can cost a lot of money that way. So, onto our main course. First, I'm going to show you a bit of the Apache Airflow backend, which is now running in my local cluster. I here have a scheduler, a statsd pod, a triggerer, and a web server. Let me increase that for you so you can also read it. And in here, the actual web server of Apache with a DAG. This is all written in Python with 3 different steps. All 3 of them are bash operators with a simple sleep for demo purposes, but this can be anything like said before. You can start with dumping data from a database. After that, manipulate it into a storage account. And as your third operator, create a report out of it and send it to your manager. In this case, we will run T1 and T2 parallel to each other, and then start T3. So I'm going to start this now. And as you can see, Airflow created multiple containers into the Kubernetes cluster. So imagine that you have a cluster with 2 different nodes. A couple of pods, like the web server, scheduler, and triggerer, and a database in your cluster. And this is all fine and well, until you start experiencing workloads. Like I said before, Kubernetes can autoscale, not only on pod level, but also on node level. If your cluster keeps getting busier, you might even get a fourth node, and you start to see things like rebalancing or redistributing your cluster. So when this happens, with your database, you get a short unavailability. Most of the time, this is all fine and well, but keep in mind that all your pods are communicating to your centralized database to keep everything in sync, like the web server. Now, in this case, the migration from the database went okay, but at a certain point in time, your workload will decrease, and Kubernetes might decide to start scaling down again. If it happened to scale down your database, the node which contains your database will be terminated. If that happens, we have a phenomenon we call bye-bye database. All your worker pods will start failing. And if that happens, a lot of users have to do some manual work to start it again, and you really hope they made their data flows idempotent. So how can we fix this? We found out that autoscaling and databases are not good friends, so we decided to implement a non-scalable database pool. We did this by implementing a taint and a toleration. A taint is something you can set to repel other node pods from a special node. And a toleration is something that you will accept it. It's like a peanut allergy. Some people are allergic to peanuts, others are not. If you are, you stay out of the way. Now, with that cleared up, we have a different phenomenon. As you can see, in my cluster, I don't have the in-cluster database anymore. That was because our development team was wasting a lot of time trying to manage the PostgreSQL database. We thought at first that it would be easier because we only had to learn one technology, namely Kubernetes. As it turned out, we had some issues when upgrading it and with automatic backups, so we decided to go with a PaaS database. Now, our PaaS database has 32 cores, which allows for 1,500 concurrent connections and 1,495 concurrent users. You would say that this is sufficient. The only problem is that Apache Airflow is implementing their database connections in a special way. I only have one DAG in my environment now, and as you can see, we scaled up from 4 connections in the database to 16 by only running that one DAG. Imagine that going over 1,000 or more DAGs concurrently running. So, how did we solve this issue? We decided to go with another non-scalable node. We reintroduced our database node, and we installed PG Bouncer on that. With PG Bouncer installed, you change your connection string from your application, and PG Bouncer makes sure that it grabs all your connections together and puts them in one single session to your database. And you can specify this over how many sessions you want to parallelize this. But at least it's using way less connections than Airflow itself would have. The default Helm chart from Apache Airflow comes shipped with PG Bouncer, but it's not enabled by default. It took us about 1.5 days to implement this, so it's really worth to do it. Not only if you have a big cluster, but also if you have a small cluster. With your small cluster, you can go for smaller database sizes. I'm currently running at 1 gigabyte of memory in my database and 1 vCore, and it's barely keeping up, but it should have been sufficient. And this is really due to the concurrent connections in Airflow. In addition to that, the Azure PostgreSQL Flexible Server already includes the PG Bouncer for you, so you don't have to introduce it within your cluster. and you can get rid of that non-scalable node pool, which was another single point of failure. Now onto the fun stuff, with no more room in the network. In our environment, we deployed Kubernetes within a subnet. Every piece of compute needs subnets and IP addresses. And we decided to go with a 512 IP address big subnet, which at the time we thought was more than enough. Oh boy, we were wrong about that. We have a couple of pods running here, which were 6 at this point in time. But we have other things like the nodes, which also require IP addresses. And we have some things in kube system. Kube system is the mandatory thing for Kubernetes to run properly. It contains things like core DNS, etcd, which is a key value store, the API server, and all other things regarding autoscaling as well. In Azure, it will also contain the drivers to connect to your storage. So you can imagine that you're already losing about 5 or 6 IP addresses per node. Now, imagine having the autoscaler back up and running again and a lot of user workload running at the same time. For us, around midnight is the time that most of our jobs are getting scheduled. Now, every pod gets an IP address and the entire subnet is filled up. Then it really happens. One of our pods was unable to be scheduled due to not getting an IP address. Now, how to solve this issue? There are multiple ways to approach this. You can either think ahead if you're using Azure CNI, which stands for Container Network Interface. You can calculate how many IP addresses you would need for your environment. For Azure, the maximum number of nodes within an AKS cluster is currently 1,000. We decided to go with 90 pods per node. So you can calculate that would be 90,000 IP addresses required. But don't forget the IP addresses that are required for your nodes as well. With 1,000, that would be 91,000 IP addresses. If you want to upgrade your node pools, you need to scale down some things first. So if you have an exactly fitting subnet, you get another issue. So go with at least double of what you expect to be, because then you can spin up an entirely new node pool or an entirely new cluster in the same subnet and upgrade seamlessly. The other solution would be KubeNet. This uses a thing called NAT, which stands for Network Address Translation, and it gets one IP address per node. With that one IP address, it will create more IP addresses in its internal network, just like you have in your home network with your ISP. You get one IP address from there, and internally in your network, you have multiple IP addresses, and everything will work properly. I'd really recommend to go with KubeNet if your developers already have experience with it, or you decide to go with another cloud vendor. And that's mainly because Azure CNI is not available for AWS or Google Cloud, and KubeNet is platform independent. If you want to go for fast and you are going to stay with Azure, Azure CNI is the easier way to implement it, but it does come at the cost of having to plan ahead. Now, not reviewing your application settings. At a certain point in time, we experienced the scaling issues with our platform. Around midnight, all of our pods are getting started, but only a couple are getting run, and a lot were having delays in starting. After investigating, we found out that our worker pod creation batch size was set at 1. That means that every cycle of your scheduler, you can only create one pod for your DAG or job to run in, which works fine if you only have one or maybe a couple of users. But with over 200 users to support and more than 1,000 DAGs, that's not enough. We went with 20 at this point in time, but we might increase it in the future to 50 or even 100. The same goes for the maximum DAG runs to create per loop. This allows to create multiple DAGs in one scheduler loop, which was default set at 20 due to the salary executor. And we decided to go with the Kubernetes executor because of the scalability from Kubernetes. So try to keep those two in sync. If you have a higher number at the worker pod creation batch size, also increase your max DAG runs to create per loop variable with it. Otherwise, you will still have a bottleneck in your settings. The last thing I really advise you to change is your parallelism. By default, this is set to 32, which allows 32 DAGs or jobs running at the same time. Now, for our environment, this was really a bottleneck. And as of yesterday, I upgraded this to 512 parallel jobs at the same time. Which brings me to our next point. Last week, we were trying to upgrade our cluster to Airflow 2.3.0. We were really looking forward to it because we wanted to use the new Kubernetes version higher than the 1.21 due to CSI drivers. Now, we also had another issue where Airflow didn't support the latest Kubernetes version that for AKS. And the version that Airflow supported was getting sunset. Now, we thought this would be an easy upgrade, like all the other upgrades were. And we were really wrong about that. We had 2 days of downtime on our development environment due to failed migrations that would normally go right. We had to do multiple rollbacks on our cluster to keep the data, to get the database back in the state where we know it is. Then we had to do manual migrations, which would normally have been automatically. During the migrations, we found out that we had some null records in tables that should not have null records, so we had to drop those. After all of that, the upgrade went successfully, but we found out that we had a huge performance impact on our web server. It was taking more than 2 minutes to load the main page of DAGs, and that's ridiculous. Normally, it would only take 2 or 3 seconds for us to load our main page with more than 1,000 DAGs. Now, after a lot of digging around and debugging, my colleague Martijn found out that the web server exposure check introduced in Airflow 2.3.0 did a select all on our logs table. Our logs table was about 21 gigabytes on our dev environment because it contains all the logs from the web server, so all the requests that come in, all the logs from the DAGs, but also things from the scheduler and the triggerer. So it's really big. To be honest, I think it's still really nice that the database managed to keep up within 2 minutes to do a select all from our logs table. But as you can see, we had I/O spiking at 100% most of the time, and our CPU percentage was also right around that. Now, if you are having issues with a non-performing web server, please make sure that you disable this exposure check. Even better, if you know that your environment is exposed, disable it already. And if you are in an intranet where you do not expect it to be, also disable it because you are contained within your environment. Now, what are our key takeaways? Don't autoscale your database and connection pooler nodes. It can cause you a real pain to debug this issue because your logs are not getting provisioned to your web server as well, and everything is failing. Regarding your database capacity, go with a past database to help your development team to get up to speed and let them focus on the things they want to focus on. Use a connection pooler no matter the size of your cluster because you can save a lot of money on it. Plan and design your network ahead and make sure that you can at least accommodate 200,000 pods running at the same time. It might be overkill for now, but you will thank me later on because enlarging subnets is not fun. Now, upgrade your application settings and try to keep up with the latest changes that Apache Airflow makes for you. There are a lot of settings that keep getting updated every release, and more are getting there every time. And last but not least, if you are having issues with your database server, with your web server, try and disable the exposure check because it's a real hard hit on your database. Next to that, I would really like to thank my colleagues Martijn, Jomanu, and Krijn, who helped make this all possible. And of course, Rabobank, the Netherlands, who allowed me to talk about our failures instead of our successes. Well, who am I? I'm Glenn Schuurman. I'm a senior platform engineer from Quintor. I started as an application developer early in my career, but I quickly came back to being a platform engineer. And I am really believing that using experiments to test a technology is the way to learn, because you can only tell if you know what you're doing if you experimented with it. Now, thanks for the attention, and I think we can go to the Q&A session now.
Great presentation, Glenn. Thank you so much for that. So for the data teams that are watching your session, Glenn, a couple questions here. What would you consider was the most costly mistake to avoid? And this can be in the context of solutions or technical debt or delays in implementation when they're trying to configure or reconfigure a data pipeline, and what should they do instead? I guess pick the biggest one or two or three.
Yeah, I think the IP address subnet would be our biggest mistake because it required a full redeployment of our cluster. Within Azure, you are not allowed to resize a virtual network. So if you specified your virtual network wrong at the first time, you cannot increase it any further than your VNet is now already, which in our case was 512 addresses.
Wow, I see. Okay, that's great. And then another question here is that I'm surely you use a DevOps framework in your environment here. Were you able to leverage that in any way to identify and pinpoint issues in around the implementation?
A bit. It's really hard to test the Airflow environment because you have to have a running instance and you have to get your authorization up and running. We rolled a custom authorization with the Azure Active Directory to make single sign-on possible. And that makes it really hard to authenticate from any pipelines to test. But we do test our Docker images beforehand to make sure that a lot of things are working. But of course, you can never guarantee that everything is working.
Sure, yeah, that's understandable. Are there other scenarios or potential workarounds that you can conceptually think of that folks can think about that might be a good fit to get around the issue?
What issue are you referring to?
I was talking about testing of the pipeline.
Yeah, I think it's always good to have multiple environments for you. Also, not only the environments that are user-facing, but also your environments that you test on yourself. In some cases, you can try and do some click-based things, but it might be harder to implement that.
Gotcha. And with such a complex project that you spelled out here, so how much human capital did it take to complete this? Is there anything that you would do differently in terms of managing people resources?
I'm not really sure. I think we've learned a lot about our database. I think that mistake was mandatory for us to make. By doing that, we found out that the autoscaler was creating some issues for us. But if I have to cross anything off, yeah, it would be the IP addresses, which we would have known beforehand, or that database in cluster, because it really had some user impact and a lot of users complaining that logs were not there, pipelines were not being scheduled correctly, and things are not getting run at the correct time.
Yep. Okay. And then I really like the note that you mentioned about leveraging community for support. I know you guys have done that throughout this process and through this project. How was that able to help you the most? Because we have an amazing community at Incorta of users that are sharing and exchanging ideas and solutions at community.incorta.com. And wanted to know about what was some of the things that you did using the community around to be able to solve through some of these issues.
Yeah, well, what we did in our environment is we created a channel for users to communicate to us, to report some issues and to ask for any support that they might require. Let it be some frequently asked questions or something like that. We also created an internal Stack Overflow-like site, and we answer the questions on that. We're really trying to make sure that the people are able to ask any question that they want and moderate and answer those questions. And at a certain point in time, your users will start to answer the questions themselves. We've seen that happen over the past week a couple of times now. And that was really satisfying to watch, seeing that your community is growing really mature and seeing that they can help themselves.
Yeah, that is definitely always very exciting to see. And it's great to have that kind of a community environment to be able to rely on your peers and other technical experts to help you through some of the challenges that you're facing. Glenn, thank you so much for being here today at Zero Gravity. And I hope you've really enjoyed the event so far today. We don't have any other questions, so we're going to start wrapping it up here. Glenn Sherman, Senior Platform Engineer at Quintor. He told us today about how you can scale up Apache Airflow at enterprise level and what mistakes you should avoid along the way. Folks, that is our last live session of track 1 on use cases. Please stay tuned as we go towards finalizing and wrapping up this incredible day at Zero Gravity by Incorta. And we look forward to seeing you at future events. Please move on to the next item on your Zero Gravity agenda. We should be wrapping things up just about the bottom of the hour. So we'll see you there. Thank you again, and hope you're having a great session. Take care.